Good morning, Web3 community, and thank you for joining us for the February Infura Community Call. I'm Chris Anatalio, and I am your friendly platform advocate for Infura. All right, Infura fam, you know what the deal is. This week, the biggest news of the week is in ETH Denver. We're going to be there in full force, supporting you in the trenches, mentoring, offering really cool bounties, and we have a booth. We have all kinds of stuff. We have some exciting events for you. And yeah, the whole community is super excited, and we're going to be there right with you. But before we dive into our bounties and some information on how best to um, position your team to win some of these bounties, we have a team member who's going to be talking about our exciting new project, zkEVM. So I'm going to go ahead and kick the mic over to Declan. Am I saying that right?
Declan. Yeah.
Declan. I'm so sorry. Declan. Okay. Yeah. So I'm going to kick the mic over to Declan.
Okay. Hi, everyone. Okay, so let me figure out how to share my screen, and I will walk you through. Let's see. Okay. All right. So hopefully you can see those slides. So good morning, everyone, or afternoon, depending on where you're calling from. So I guess for the next 20 minutes or so, I'll be discussing the new zkEVM by ConsenSys. I'll try and give like a quick overview first, just of rollups, and then hopefully by the end of the talk, you'll have a clear understanding on why we think that the zkEVM is the next big step in adoption for Web3, and then also how Infura is set to play an important role in that journey. So first, a quick intro. I'm Declan. I lead the product roadmap and strategy for the zkEVM, where we recently announced the launch of our permissioned private testnet. I've been in the blockchain space for nearly 5 years, previously working on tokenizing real-world assets like bonds, equities, managing the lifecycle of these assets on Ethereum. Before crypto, I founded a health tech startup and actually began my career in the automotive industry, working on driverless electric cars. So a bit of a mix. Okay, let's get into it. Okay, so yeah, on the menu for today, I'm going to be covering firstly just like why rollups, just a quick overview, as well as like optimistic versus CK rollups or zero knowledge rollups, and then talk more specifically about the zkEVM rollup, as well as the sort of recent testnet we've launched, and then the next steps coming in the roadmap as well. So there'll be some familiar and basic concepts initially, but I kind of plan to introduce some more advanced concepts towards the end. Hopefully everyone will be able to learn something new. Okay, so quickly then, why rollups? I want to start by taking a big step back. I expect most people were familiar with the blockchain trilemma. It's pretty simplified, but the blockchain trilemma states that you can only focus on 2 of these 3 properties. So scalability, security, and decentralization. For example, Bitcoin and Ethereum are secure and decentralized, but they do not scale. Chains like Tron and Ripple do scale, but they are secure, but that's because they're centralized, right? So it kind of defeats the purpose of a blockchain. So we're yet to conceive a network that really features like watertight security over a widely decentralized network while being able to manage internet scale transactional throughput. So, and the reason for that is because they're all monolithic blockchains. So these monolithic blockchains try to do too much. They take on the responsibility of 4 key properties, which, as you can see, is data availability, consensus, settlement, and execution. Remember this illustration because we'll actually come back to this a bit in a little bit, but you can see here the different sort of operations at play. So what happened? So this industry realized this sort of scaling issue and actually experimented with a few different scaling solutions. If people remember, we first started off with state channels where only a pre-agreed set of parties could transact amongst each other. Then we had Plasma where anybody could transact. And then eventually we landed on rollups, which is kind of a solution that solves censorship as well. So what is a rollup? A rollup is actually just kind of a blockchain. It's a blockchain that batches and executes transactions off-chain, so off the mainnet, in an environment that is optimized for the execution before then actually posting that block data back to another blockchain like Ethereum for consensus and data availability. So you can kind of visualize a rollup as an extra layer on top, which is why we often talk about it as a layer 2. This is very different to a sidechain or a commit chain. So chains such as Polygon Proof of Stake actually needs to bootstrap its own validator set for security and has its own trust assumptions, whereas a rollup gets to inherit the security and trust of Ethereum itself. So a sidechain is actually just another monolithic blockchain, which means it suffers from the blockchain trilemma. It trades off, either decentralization for security. Polygon, for example, has 100 validators, whereas Ethereum is now close to like 500,000, I believe. So a rollup actually borrowing the security of Ethereum is more decentralized and secure than one of these side chains. So this is actually why Polygon have made such a big investment in the rollup space as well. And then another big difference is the sidechains rely on trusted bridges, so multi-sig bridges to connect to the hub of Ethereum. I'm picking on Polygon a bit here, but like there's many different chains who have this model, which obviously these chains are subject to lots of hacks. Whereas rollups use native trustless bridges, which give you much better trust assumptions, much more security than multi-sig bridges. Okay, so the reasons they're so effective is because they optimize the rollups. They optimize for the execution. The computationally heavy execution happens in the modular stack, and then they rely on a far more decentralized and secure base layer, for example, on Ethereum, for that settlement, consensus, and data availability. And as most people probably know, the rollups are already here. This is a screenshot from LTB. It's a little bit old, but you can see there's kind of over 5 billion in TVL across all the Ethereum roadmap rollups. Rollups like Optimism and Arbitrum, which Infura supports, are now actually generating like more revenue than some Autel ones, like Avalanche, for example, which is really interesting. But not only that, rollups don't need to issue tokens to provide security. So, for example, to incentivize miners on the Bitcoin network, there is a block reward, but this block reward comes from newly issued, BTC tokens, which inflates the currency and is an effective tax on token holders. So the cool thing about rollups is this isn't the case. A security is actually handled by Ethereum and the ETH token. We're now seeing more activity consistently on L2 than mainnet itself. So there's 2.7 times more transactions happening in the greater Ethereum ecosystem because of rollups. Probably we'll soon see a hockey stick moment where layer 2s reach escape velocity as well. Okay, so theoretically, rollups help us to get to hundreds of thousands of transactions per second. Ethereum right now can handle anywhere from like 15 to 25 based on what transactions they are. But this scalability will allow us to kind of introduce new types of services and dApps to blockchain, to crypto and Ethereum, such as like social, gaming, content and media. But the limitation is just creativity at this point. And this is 100% committed to by the Ethereum Foundation. They have a rollup-centric roadmap which talks about the goal of rollups and the surge being to scale beyond 100,000 transactions per second. Okay, so just very quickly then, what's the difference between the different types of rollups? The two main types, optimistic and zk. Optimistic rollups use economic incentives to keep bad actors in check. So for an optimistic rollup, if a layer 2 tries to submit an invalid transaction to layer 1, then you have these watchers which can detect and report fraud. And if that fraud claim is valid, the watcher is financially rewarded by slashing the deposit of the layer 2 operator. So, Optimism and Arbitrum are like two leading types of optimistic rollups, which you can access through Infura as well, as Infura is now, has multi-chain support. zk rollups or zero knowledge rollups, on the other hand, use cryptography and maths, not watchers, to verify computation and keep things secure. So in this case, for each batch of transactions on the L2, the operator submits evidence to the layer 1, like Ethereum, for example, in the form of a validity proof, which actually verifies the integrity of the state transitioning happening on the L2. Okay, so an example of another zk rollup is Starknet by Starkware, which is another Infura also supports. Okay, so like what's the problem? Well, optimistic and zero knowledge rollups today are not completely serving the needs of the ecosystem for scaling. So at ConsenSys we have a a leading R&D team, same R&D team that helped deliver the merged, design the engine API, manage and maintains, execution and consensus clients like Besu and Teku. So we have a lot of knowledge in the space, and we also have a deep experience with rollups, having worked in that space since 2019, back when most of the focus was on optimistic and not zk. And we found that there are kind of like two critical problems still. The first was like basically a lack of EVM equivalence, so a lack of being compatible with the EVM means it's difficult for developers to use existing tools like Infura or MetaMask or Truffle. That means they have to potentially rewrite and re-audit their smart contracts, which adds a lot of time before they can move to layer 2 to get the scalability benefits. You just sort of lose that infrastructure network effect from the EVM, which has kind of become the standard protocol in crypto. So that's really slowing down adoption. And the second one is that even though some optimistic rollups do have that EVM compatibility now, there's actually quite a few trade-offs against zk, such as like the different security assumptions, for example. They have a longer finality time by not having this delay window to L1, which means sometimes withdrawals can take up to 7 days rather than just like a few hours or a few minutes. And also there's some scalability challenges as well, because you actually, with a zk rollup, post less data on chain. So there's actually more potential for scalability as well with zk. Okay, so that's a quick overview of like how we got here and why ConsenSys thought about developing a zkEVM rollup. Let's talk a little bit about, firstly, what is a zkEVM rollup. So we go back to our sort of illustration of a regular serial knowledge rollup from earlier. So Ethereum is the layer 1, and in this case, for us, ConsenSys will be the layer 2, public permissionless. The L2 is executing batches of transactions, it's generating validity proofs, and then it's actually posting that data back to L1. So that is it in a nutshell. But what's the difference? So if you actually dig a little deeper, you can see that the L2 blocks are essentially consolidated into L1 transactions. So that's how you get this scalability benefit. You're sort of like taking a set of linear statements and then condensing it into a sublinear, verification on L1. So that is what's happening in a zkEVM rollup. But the cool thing is that you also get to reuse, already deployed bytecode. So you can take a smart contract, for example, the Uniswap, V3 contract that's already on Ethereum inside the EVM, and it's been audited and battle tested, and you can actually take that and then deploy it directly on L2. So that whole process of migrating from an L1 to L2 is super seamless. So as a user, you can get all of your favorite dApps, but for ultra low transaction fees. It's as simple as that. And then, for developers as well. So additionally, with a zkEVM rollup, your interface is exactly the same. You use the Ethereum RPC interface. So Infura works out of the box, Truffle as well, makes it really easy to start building on layer 2 with an zkEVM that is EVM equivalent. So the goals of our specific zk rollup, our zkEVM, so we want to, it's kind of 3 main goals. Firstly, we want to execute what we call unaltered native bytecode. So the actual bytecode from compiling your Solidity contracts, we actually will execute that inside the prover as specified in the Ethereum yellow paper. So we don't do any modifications to that. We hope to have 100% coverage of all the different opcodes. There's many different opcodes and pre-compiles. We aim to have complete coverage of all of those so that we have a fully trustless solution. And we also plan to be a type 2 zkEVM, which is a classification in that Vitalik gave, and a lot of people sort of adopted now. Basically what this means is that you can verify an environment that looks exactly like Ethereum but with minor changes. It's pretty much fully compatible with 99% of Ethereum dApps, and you can share most of the infrastructure. There's a few differences in terms of how you represent the state, but otherwise it's pretty much the same. So just sort of a high level as well, like this is a useful illustration to kind of show, type 2 zkEVM is really just the Ethereum experience, but like at scale. So here you can see different levels of compatibility with the EVM, and I'm not saying any of these are necessarily better, but they're just different options for developers and users when they're thinking about their L2 journey. So, as you can see on the right-hand side, have like Polygon, Scroll, ConsenSys, all of these are sort of taking compiled bytecode like Solidity or Viper using the Sol-C compiler, and then they're aiming to actually try and either directly prove that bytecode or, map it to some micro opcodes to then actually interpret in their own sort of execution engine. So the kind of key difference here in architecture is all about how you reduce the number of constraints versus proving the EVM directly. So some teams decided to kind of have this extra step to reduce the number of constraints, which might lead to more performance potentially, but then you're also having to introduce some modifications as well, which could lead to some divergence from Ethereum. So it's great that we have all these different options basically, but it's a complementary solution. There are 4 rather large challenges to building a proper zkEVM. So first is complexity. It's like EVM was not designed for zk, so it's that's composed of many parts, all very coupled. Secondly, you have the sort of historical and complex behaviors of the EVM, which makes it very challenging for arithmetizing the operations in that constraint system. And then also you have to think about auditability. So this is quite new technology. We need to make sure that it's easy for third parties and people to audit the system, make sure everything is doing what it's expected to do. And then lastly, performances as well. Like, how do we get this to a level of performance which is actually going to ultimately enable low-cost transactions for users? So we decided to tackle each of these challenges head on. Firstly, for the complexity, we have a modular design. This makes it really easy to decouple the different components. In terms of the intricacies, we actually have published, it's currently 250 pages spec. We're going to update that soon, and it'll be around 300 pages, and that details exactly how the constraint system works. It's very, very detailed. For auditability, we have a single source of truth as well. So there are usually like 3 moving parts: the spec, the implementation, the verification. They can be developed by different teams. We managed to bring it all into one single source of truth, so not to have diverging code bases, making it easy to audit. And on the performances side as well, we published some recent benchmarks. So the prover that we have, which is a lattice-based prover, which is something we published in December, we can show that we're actually proving around 30 million units of gas in 4.5 minutes. Like, it's not the target, but it's a really good start. It's actually the leading benchmark that's been published. And that is on a 96 CPU core machine as well. So lots of great stuff there. But our target is to get that down to around 15 million gas in the time of 1 block, so under 12 seconds. Okay, so current results are very promising. The way we're measuring this is with the EVM test suite. We have pretty much, we have 92.6% coverage. We're still missing some of the EVM precompiles. Once we've implemented those, we'll have 100% coverage and we'll have a fully trusted solution. So that's coming very soon. We're actually performing this on real world examples, real mainnet blocks, and we obviously have our testnet as well. So I will talk about the testnet very quickly. So we recently launched a permission testnet. We actually started opening that to external people on the 9th of January, so not that long ago. Some quick highlights. So right now as a single operator, as ConsenSys, we plan to decentralize in the future, but to bootstrap the network, it will be centralized. We're exposing this via Infura. So this is amazing, where like all the dApps will use Infura initially to interact with the network, which is amazing because we get the reliability of Infura for that purpose. We also have a block explorer for both Go Early, and the L2 and the zkEVM. So for each block, we're actually verifying transactions and posting validity blocks on the Go Early testnet, so proving that use case out. We have integration with Truffle, with MetaMask, and there's comprehensive documentation as well. So you have the full feature set there. In terms of benefits, EVM ready, compatible. You don't have to. There's no waiting periods. So when you bridge from L2 to L1, the idea is that you will be able to quickly withdraw your funds. Validity proofs, like I said, and then obviously cheaper than mainnet as well. Like I say, with Infura, it's been amazing. So in January, we had 200 million calls via Infura, which is quite a lot, and we had 100% uptime. So our users are getting, super great service because of that integration. And that's one of the kind of benefits of having this within ConsenSys, is that we get that close connection to other ConsenSys products. We have a website. So this is the website. Basically, when you onboard, you go to this website, you fill out the testing environment setup, and that gets you all set up to use it. You can bridge. You can then start play integrating with all of the different dApps that we have. It's a nice little user-friendly onboarding process. So, crypto natives, but also new people to Web3 can easily do this and start using L2. And then, so just in terms of where we're at, so we have this permission, private beta testnet. We had over 350,000 signups, which is a lot. We've now closed the registration for that, and our focus is really just to kind of onboard that backlog. We're making really good progress. I've had lots of transactions now due to onboarding. We're hoping to have everyone onboarded within the next few weeks, hopefully sooner. I appreciate that there's a bit of a, there's a lot of people who are still waiting for that allow list, and we're doing our best to kind of get them onboarded as soon as possible. For developers and teams, you can submit your dApp project. So you just click here and you can see all the different dApps that have already submitted. There's a lot more since I took the screenshot, and there's a lot more in the pipeline as well. So that's really exciting. And then just kind of quickly to wrap up. So we're currently on our permission testnet. The next phase is really to open it up to the public. So once we're happy with the testing phase, we'll open that up so that anyone can access the testnet. And then it's just a sort of head down march to mainnet later this year. I don't have any dates for you, but that's the sort of high level plan. Okay, so just kind of quick summary. So why ConsenSys L2? Well, firstly, why zk rollups? More throughput, more scalability for us at least, more trustless, cheaper than Ethereum, which is amazing. That's the whole point of L2. That fast finality, infinitely scale. Then we have the EVM equivalents as well. So basically you can build as if you're on Ethereum, which is great for developers. If you actually already have an existing dApp, then you can keep your code without having to rewrite or re-audit any of it, which is also great for vendor lock-in as well. So if you decide to deploy your smart contract and you don't like the network, you can always move away. It's great for decentralization in that respect. And then also with ConsenSys, you get that amazing performance that I shared earlier, all led by the sort of gigabrains of ConsenSys R&D who have delivered so much for Ethereum. And also you get the amazing integration with things like Infura, where you get that 100% uptime and, the amazing benefits of Infura. So I will end there. Maybe I'll stop sharing. Okay. Yeah.
Cool. Thank you so much, Declan. They do call zero knowledge moon math because supposedly it's so complex and inscrutable that people can't understand it. But I think you did a fantastic job breaking that down in really, really like simple, common sense terms. And yeah, it seems like such a game changer from a scalability perspective, without even factoring in additional things like fractal scaling. I just learned about you could actually zero knowledge multiple layers, and it's a whole rabbit hole, but yeah, it's amazing. So yeah, thank you so much for breaking that down for us.
Yeah, thank you. Yeah, if I had another 10 minutes, I could have gone into fractal scaling, but we'll save that for another talk. That's a very interesting one.
Yeah, that's a whole other rabbit hole, but yeah. All right, cool. Now that we talked about ZK, let's jump back into the main event, ETH Denver. So Infura is going to be there right with you. We're going to be hosting so many cool bounties. So let's go ahead and dive right in. So the first one we're hosting is kind of an open-ended one if you want some creative freedom. Basically, you just have to build a multi-network deployment with Infura. You got to deploy to multiple networks, such as Ethereum or some of the L2s, such as Polygon, Proof of Stake. But basically, that's it. Just check all the boxes, deploy with Infura, and use Truffle. And Yeah, just let your creative juices flow. Oh, hey, look who we have. We have Emily Lynn who just joined. Thank you for joining, Emily. Our next bounty is for people who are interested in social DApps. So if you've heard of Lens Protocol, it basically is a open source on-chain way to implement a social app, implementing all the common features such as follow, comment, all of that, but in a Web3 native way. So if you're interested in Web3 social DApps, and you want to build with Infura, we have this awesome bounty with two winners. You just got to build using the Lens protocol, decentralized social graph, using Truffle and Infura. Doing a multi-chain deployment, always extra points. But the main thing is a novel social DApp use case to really qualify for this bounty. Next up is Ethereum archive data. So basically, archive data is anything older than 128 blocks. So you're looking at data from back in the day. So why would you care about old data? Well, maybe you want to do like a back testing algorithm for automated trading, or maybe you have a analytics platform that you want to build out. Maybe you want to build out your own version of Dune Analytics. So, like, basically, anytime you want a historical view of Ethereum data, uh, you could use archive data. And with Infura, you get free archive data up to 25,000 requests per day. So, if you're interested in this bounty, definitely check it out. Um, all you got to do is build something leveraging archive data using Infura and, novel use cases, things which are a compelling narrative, definitely help your odds. So definitely check out this bounty if you're interested. And then for the more security minded folks, we have a split bounty between Diligence and Infura. So if you're not familiar with Diligence and Scribble, Scribble allows you to perform something called fuzzing, where basically you are kind of trying to check out all the various states that your smart contract can be in to kind of preemptively determine if there's any potential security flaws or bugs in your code without having to submit to a formal audit. Uh, so if you're a security minded person, if you're into security auditing or automated security scanning, this might be the bounty for you. Basically, you want to contribute Scribble properties and deploy using Infura. So this is a really cool bounty for those of you who are into security and that kind of stuff. And then finally, this bounty is more for maybe the Web2 developer who hasn't really built out a skill set in smart contracts or Web3 yet. Infura offers a NFT API and SDK, which allows you to integrate rich NFT functionality into your app while using traditional REST API and TypeScript or Python SDK skills. So basically, if you're a Web2 developer and you want to integrate NFTs into your app, this might be an awesome bounty for you. And we have 3 winners for this bounty, so there's lots of room for creativity and novel, compelling use cases. So definitely check it out. The NFT API helps you abstract away a lot of the smart contract complexity, allow you to query all this rich NFT metadata, as well as, sorry, my cat just walked on my keyboard, allows you to also mint NFTs all programmatically using the NFT API. All right, now, if you want some alpha on how to best position your team to win some of these bounties, here are a couple quick tips. Um, it's a hackathon, so obviously you want to write the code during the duration of the hackathon. If you show up with the project you wrote last year, you might get disqualified. That kind of doesn't align with the spirit of a hackathon, right? A hackathon is about hacking. So you want to write the code during the duration of the hackathon. So you kind of want to make it clear that your GitHub repo and all of your fresh Git commits were made during the duration of the hackathon. You know, Documentation always helps. You might want to talk about some of the problems you ran into, how you overcame them. You want to make sure your GitHub repo is clearly linked to your identity. You want to add, clear info about your team, all the basics. Another important thing is taking some time to craft a compelling narrative. Like as judges, we're just people. Sometimes we might not have the same vision as you. So if you take some time to really explain why your idea is so cool and to help us understand why it's such a compelling idea, that could definitely help us connect the dots and, you know, gives your team a much better shot at being in the running to win some of these bounties. Um, Being able to explain your idea in simple terms definitely helps, and having a clear user interface and user experience definitely helps. It's a time boxed uh, endeavor, but it doesn't have to be super polished. But if it's clear how your idea works in your UI, that definitely helps us understand your amazing idea. So it's 2023. If you're just minting ERC 721 NFT, that doesn't really move the needle. Novel use cases generally have a better shot at winning. So, check out what's out there already and, try to build something that's really eye catching, that's really novel and unique. That's how you're going to position your team to like really have a good shot at winning some of these bounties. And another thing that teams sometimes get caught up in, they're sometimes too aspirational. They're trying to do too much. Sometimes it's better to cut scope, do less and have a fully functional app. It's better to have a small set of features that really work as opposed to a lot of different features that you tried to get working and don't quite get to the point of mainnet, you know. So make sure to constrain yourself to like what they call a minimum viable product, that minimal set of features that really demonstrates your compelling use case that you're trying to show. Because to have the best shot at winning, you want to have your code deployed to testnet. You want to have your UI live. You want to have something that's actually working. That's going to really that's what's going to wow the judges. All right, so I am going to go ahead and kick it over to Emily real quick. All right, Emily, are you ready to hop on?
Uh, yes. Am I visible? Can you hear me?
Yes, yeah. Since I gave you the spotlight, yeah.
Okay. Why am I a black screen? Oh, goodness, guys.
Oh no.
Let me refresh.
Okay. Well, just to introduce Emily, you all probably know Emily as the truffle developer advocate. But as you also know, she's a little bit of an overachiever. So she is actually also the developer advocate for zkEVM, working with Declan. So Emily is going to be supporting Truffle as well as zkEVM.
Hello.
Now we can see her.
I'm back. I'm back. What did you say
Yeah,
about me? I hope only good things.
I was calling you an overachiever because you're now the
Ah,
Truffle developer advocate, and also the zkEVM truffle.
Is that an overachiever? I'm just spread too thin now. But yeah, I mean, like for the capacity of ETH Denver specifically, I will be supporting primarily Truffle. I don't remember why I'm on this call to talk about mentorship, correct?
Yeah. If you want to talk about mentoring for the build-a-thon,
Yeah. So I guess like two things. Did you cover the truffle bounties either?
no, I
No,
did.
yeah. Okay, cool. So Truffle has a few bounties that we're offering more so in conjunction with Infura. So I'll just go ahead and touch on those. Um, and let me find them. Okay, cool. So we have 5 bounties. So each one is $1,000. So first off, there's test locally with 0 config forking using Ganache. And so this is kind of tied into Infura specifically, because if you remember Chris mentioning about like archive node access, actually Infura offers that for free for Truffle's Ganache. So that allows you to basically replicate the state of mainnet locally on your machine. So if you're testing a contract that you want to interact with a mainnet contract, you can do that without ever having to spend like real ETH. It's all fake. It's happening locally on your computer, so it's super fast. So we want to just see you use that in your dApp. The other one is deploy your dApp on Infura with Truffle Dashboard. So if you guys know Truffle Dashboard at all, it's basically a means for you to sign transactions and deployments through your MetaMask wallet. So if you're used to development and like putting in your like private key in a separate environment, you don't have to do that with Truffle Dashboard. And so those two are going to be bounties that you can use with whatever CLI you want of your choice. So if you're using Hardhat, Foundry is not compatible with Truffle Dashboard, I think, but that's basically the two you would want to aim for if you don't want to start with a Truffle um, config. Otherwise, the next 3 are going to be if you want to start with a Truffle project specifically. So deploying a dApp on an L2, um, building a MetaMask snap. So if you guys know MetaMask snaps at all, that's kind of like extending wallet functionality. So things are snaps that have existed are, for example, making transactions more transparent through like showing you what the parameters are as you make a transaction call, or making MetaMask wallets non-EVM compatible is another MetaMask snap. So Truffle, you can actually, we have a snaps box, so scaffold code to integrate smart contracts into your snap. So using that one. And then the last Truffle bounty is going to just be using the Truffle React box. That's like a simple setup of just here's your smart contracts, here is your React front end, and use them together and then deploy on Infura at the end. So there's actually a lot of room for applying for multiple bounties here. So if you choose like one of our truffle bounties, it will most likely overlap with one of the Infura bounties. So you could rake in some dough, you know what I mean? Um, but anyways, to that extent, like talking about mentoring, I'm not sure what to cover here other than like we'll be there. So I'll be mentoring, so will Chris, as well as Lauren, the other Infura DevRel. There's a few people from the MetaMask team also mentoring. What that looks like is, I guess we'll be sitting around waiting for you to come talk to us. I am super, like, we're all super friendly. Like, we're here to help you be successful. Um, so yeah, I'm excited. I'm really excited about this like zkEVM best tech. Yeah. So if you want to talk about that, I'll be at the booth as well. Um, but that's all I have to say. I don't know. Is there anything else you wanted me to cover?
No, mainly I just wanted to leverage your star power for my community tool. So.
Star power? What are you talking about? I'm only famous to you. You
Yeah.
know? But I guess quick plug, if you are going to be attending ETH Denver, I'll be giving 2 presentations. So for those of you who are like smart contract developers, I'm going to talk about smart contract tooling at the Interop Summit. That's Feb 28th. But if you'll be attending the actual event, I'll be talking about open source tooling in general, like public goods stuff. It's kind of spicy. That's my goal when we talk about Truffle's history. Um, I was like looking at the description I wrote and I was like, holy, whoops, whatever, it's public. That's fine. Yeah.
Cool.
Cool.
All right. Well, thank you so much for joining last minute. And
Yeah.
yeah. Awesome.
Thank you.
Cool. All right, everyone. So just quick reminder to follow us on Twitter. At Anatalio. And our other, if you're a platform advocate, is at Lauren MXV. Be sure to check out Emily Lynn's Web3 Unleashed series to build a NFT marketplace step by step. I'm not sure if this is still valid, Declan, but we have signups for the zkEVM private beta testnet. And be sure to join us on Discord, on Twitter at Infura_IO. Be sure to reach out if you have any questions, and be sure to follow us on YouTube. Now let's dive into some questions. Let's see if we have anything good in here. Let's see. Please explain about merging. All right, Declan. So you were totally right. A lot of these questions are, I have registered for the zkEVM testnet many times. Why is it not activated for me? This has been updated. This is our top question. So Declan, if you wouldn't mind addressing this question, which you kind of saw coming.
Yeah, sure. I can give a quick overview. So, like I mentioned on the slide, so we actually had 350,000 people sign up, which was a great amount of interest. People are clearly very excited for the zkEVM for scaling Ethereum. So we've been working really hard to onboard everyone. We've actually closed the signups now for the permission testnet. So we did that just last week or the week before because we had so much interest. We wanted to make sure that we onboarded everyone. So they're closed for now. We're onboarding the waitlist. We've done about a third of the waitlist so far, and we're actually onboarding anywhere between sort of 1 to 10,000 users a day at the moment. So we are hoping to have everyone onboarded within the next few weeks. Everyone who signed up will be onboarded. It's just a matter of when, and that's kind of dependent on how much the activity sort of interrupts for example, the operation on the testnet. So making sure the bridge doesn't get too congested, these kind of things. So we're sort of tweaking the onboarding each day. But if you have signed up, then you will be onboarded. You will have a chance to test the testnet whilst it's still permissioned. So yeah, please just be patient for a couple more weeks or so, and you will get an opportunity. If you do feel like you've registered a long time ago and you haven't had access, and there's something might be wrong, it's unlikely, but you can always head over to the Discord. We have a Discord channel for the zkEVM. We have an amazing community team there who can help to to answer your request and make sure that see whether you have actually been onboarded or not, and whether you should see the zkEVM inside your Infura account. So yes, do not fret. You will all be able to experience the testnet very soon.
Okay, so basically, our community just gave the sign-ups a hug of death, and we're trying to catch up. All right, that sounds about right.
That's pretty much accurate, yeah.
All right, so let me see. Since developing solutions and providing free blockchain services consumes a lot of money and resources, have we considered a solution to help support programmers? So I assume this is talking about maybe like a startup accelerator type program. We do have a program in the works to help support startups. I think that's beyond the scope of what we have time for today, but we will be sending out information about that program. So don't fret. We're going to have more resources out there to support all the amazing startups building on Infura. So in closing, I hope to see you at ETH Denver. Come visit MetaMask or Infura at our booth. We're going to have all kinds of cool events, not just development related, some of them more networking and fun related. So definitely check out all the communications we're going to be sending out about all of our events at ETH Denver, and be sure to participate in the Build-a-thon for a shot at winning some of that sweet, sweet fiat money, which will be delivered as crypto, I think. But yeah, no, definitely get your team ready for the Build-a-thon this week. Oh my God, wow. This Thursday, ETH Denver. Yeah, I guess we'll see you there. All right. Well, thank you so much, Infura fam. Thank you, Web3 community. And we'll see you at the biggest event of the year, ETH Denver. Be sure to raise your sporks. Don't forget your MacBook charger. And yeah, we'll see you there. Thank you so much.